The area of a circle depends on the radius of the circle. The distance an object travels at constant speed along a straight line path depends on the elapsed time. The interest paid on a cash investment depends on the length of time the investment is held. In these examples, one variable's quantity depends on the other variable's quantity. We could call one x an independent variable, and one y the dependent variable, claiming that y depends on x. We would say that y is a function of x, and write this fact symbolically as y equals f of x. This leads us to our first definition. A function f from a set D to a set Y is a rule that assigns a unique, single, element f of x and y to each element x in D. Here, the set D refers to the domain, and y refers to the range. For simplicity, the domain represents the input, and the range represents the output. A function from a set D to a set Y assigns a unique element of y to each element in D. Often, functions are represented as an equation y equals f of x. When done so, and the domain is not stated explicitly or restricted by context, the domain is assumed to be the largest set of real x values for which the formula gives the real y values, which is called the natural domain. For example, the domain of y equals x squared is the entire set of real numbers. To restrict the domain to only positive values, we would say y equals x squared, when x is greater than 0. A function is like a machine, where an output value f of x is produced in its range whenever it is fed an input value x from its domain. Think of a keyboard. When the X button is pressed, the X is typed on the screen. An arrow diagram is also a useful tool to recognize the function of functions. Each arrow associates an element of the domain D with a unique or single element in the set Y.